Thank you very much. Thank you for introducing me. Thank you. So it was a quite nice introduction. I don't really need to say a lot about me. My name is Serhat Can. Thanks for pronouncing my name. Whenever I speak at conferences, if they don't specifically ask me, they pronounce my name as Serhat Can. So that's all right as well. So I'm working closely with the Opsgenie team. I'm the technical evangelist for Atlassian. Again, I'm an AWS community, so if you want to chat about AWS, if you're an AWS user, I will be around after my talk, so let's stop by and say hi. But today we are going to talk about incidents. So that is the main topic I really worked on in my team at Opsgenie, because we are an on-call and incident management solution. But today we are going to specifically focus on microservices. So before we start, I would like to know if anyone had any experience dealing with an incident before. Anyone? Okay, a couple of folks, nice. So who here runs microservices then? Okay, nice. More of a microservices, but we are going to talk about specifically incident management because that is really valuable, especially in microservices. The reason is clear, because obviously if you want to move fast, you're going to have some headache along the way, right? I mean, it's not easy, because if it was easy, everyone would just do microservices. So to move fast, you have to slow down for a while and get ready. And really, as the tech industry, we do our best to be robust and fast. And many things, mainly these, that we can also think as the DevOps, are complementary to microservices. Without these, we wouldn't be able to do proper microservices and implement a microservice architecture. We have to think about continuous integration and continuous delivery from the start. We have to think about automation. We have to think about observability. And nowadays, we start talking about the importance of chaos engineering as well. And one of the first examples of microservices came from Netflix. Obviously, there's no microservices talk without a mention of Netflix, so I'm just doing that. So you can't. So while doing my research, I came across this slide from Dave Hahn. He's a senior engineer from Netflix. He has great talks, so if you haven't watched his talks, please do so. So Dave Hahn was showing Netflix's microservices architecture, and as you can see, it is really, really complex, and it's really like a brain. And he's really like a brain surgeon, because microservices, or let's say distributed architectures, distributed systems, are really one of the most complex things that humans build. And it is really hard to manage this kind of complexity, learn how to work with this kind of complexity. So you have to, that is why you have to invest a lot in operations, right? And Netflix exactly did that. So they knew some things probably, but they learned a lot along the way. They learned what it takes to run hundreds of thousands of different microservices at scale. And they had a lot of chaos along the way, as you can see. So that is why they had many tools open source on GitHub, like tools like, many of you know, Chaos Monkey. It's part of CME Army. Tools like Atlas Vector, they have a lot of different tools just to make microservices more resilient, right? That is a clear sign that microservices is not easy. And in microservices world also, things are so ephemeral and often complex in the big picture that preventing accidents aren't really a thing. So as stated in the Google's SRE book, which I really recommend for you to read, it's a great book, they say it is more profitable to focus on speeding recovery than preventing accidents. So you have to invest more in monitoring than just trying to prevent incidents, because you are going to have them along the way, and that is the fact. So when I was preparing this presentation, I was a little bit worried that I chose a too broad topic. So because, as you can see, incident response has a lot of different steps that we need to cover individually. And I didn't even include cross-cutting concerns, for example, stakeholder communication here. So especially major incidents are complex, and the focus and scope can be very big. But we are going to focus on five important things that I believe are more important when especially we talk about microservices and incident management together. So I divided my presentation into 5. First, we are going to talk about service level objectives. Anyone heard about service level objectives before? Two person, nice. So that is why I'm happy to put the service level objectives in my presentation. So we are going to then talk about how on-call ownership changes with microservices, and we are going to continue with incident response roles, which mainly focuses on the roles involved in major incidents. How do we approach major incidents, and what roles are required to deal with those kind of complex incidents. And then we are going to talk about a little bit about tracing, because that is very important, especially we are talking about microservices, and we are going to close with alerting. So let's start with the first one, service level objectives. So service level objectives, you can think of them as objectives, but for reliability. We use them to make data-driven decisions about reliability, which is very important. So we set a target level for reliability for our services customers. And above this threshold, most of our customers should be happy, and below this threshold, our customers should start complaining. So I really like this tweet from Andrew Clay Sheffer. He's also one of the DevOps Days Global organizers. Probably you know him. He's one of the initiators of this whole DevOps movement as well. So if you are really excited about service meshes and you have no idea what an SLO is, it's kind of a bad smell, right? You might be doing something wrong. So you have to know service level objectives, and you don't have to name your objectives service level objectives. That is a term coming from the SRE book, Google's how Google does DevOps, mainly site reliability engineering. They use the term SLO, but it is mainly about setting an objective for your services around reliability, setting an objective around reliability. And I want to talk about some of the key characteristics of a good SLO. So this is a good example, right? 99% of all HTTP calls will be successfully completed under 100 milliseconds. So this is something that our clients would be interested in, right? Seeing. So the first key of a successful SLO is to focus on user happiness. What I mean by user happiness, for example, for your team, it might be important to have, let's say, 80% test coverage, right? That is very important because for you, that kind of shows the level of maturity of your system, because you can, if you test your code before going to production, probably you won't break a lot of things that kind of give you some safeness, right? You go to production by testing a lot of things, but that is not something that your users care. Just like in a keynote, you know, architecture is very, very important, but your users really have no idea what your architecture is. They don't care. It is the same here. So you have to focus on your users' happiness. When I say your users, it might be other service teams as well. So they're running their services depending on your service in a microservice architecture. So they still don't care about your test coverage. They care about things like, so they're, let's say, communicating via HTTP calls. So they care about the success rate of your HTTP calls and the speed of your responses. So that is why you should focus on things that your users are interested in seeing from you from a reliability perspective. And sometimes when we set up an SLO, our first thought is, why not 100% availability or in every call? But that is really not possible, so it is not achievable. And you have to negotiate with the service team and come up with an agreement. And please don't come up with even like 5 nines or 4 nines, because if you look at the table, I didn't put the table here, but 4 nines is like a couple of minutes of downtime every month, so it might be harder as well. Start small. Depends on how critical your service is, for sure. If you are talking about a service that many other services depends on, that might be more important. But still, be rational, because you want to have a room to improve, right? You can't deploy. You can't have the confidence to deploy every day if you're just worried about one-time deployment, one minute failure, right? So the third one is you need to have a service level indicator. And here, the service level indicator is number of successful HTTP requests divided by total HTTP requests, which often we call success rate. So you have to have some sort of measure, what we call service level indicators in the SRE world. And finally, we need continuous improvement, right? We need to review our SLOs every 3 months, especially when you start setting up new SLOs. You won't be able to set them right. You have to, I can assure you your first SLOs are going to be wrong, but you have to talk with your team, you have to talk with your clients and evaluate your metrics and improve these SLOs, for example, every 3 months. And there are a lot of great suggestions in the SRE book about how to create the SLOs in the right way. So the second one, the second topic we are going to talk about is on-call ownership. So if you are doing microservices at scale, and if you don't have developers on call, if you just have like a small team doing all the on-call, getting all the alerts, and dealing with all those alerts, it's not going to work. It's a failure. I mean, I assure you, you are going to fail. So you have to, microservices is about owning your code, creating like small service teams that, that provide services to other teams, so they have to own what they built. And it's one of the key features of microservices. So if you want to move, like you want every team to move fast, you have to put developers on call. So, the True Pizza team story, right? Amazon CTO Werner Vogels came up with this idea over a decade ago. So you have to have teams that can be fed up with 2 pizzas, so not that big, but not that small, kind of a mid-sized team. So we usually talk about these teams like they create code that is manageable, but it is very important that these 2 pizza teams should also take care of all the problems their code, all the incidents that their code creates, and they have to, let's say, wash dishes and throw the trash by themselves. So they have to take all the others. And there are many benefits in doing so. And again, like if you are talking about SRE, I really like this too as well. SRE's job is not to take on the operational burden. So you don't, if you are an SRE, you don't, just route all the alerts to your site reliability engineer and expect him or her to deal with all those problems. You want those guys to automate a lot of things to work on speeding up developers instead of dealing with alerts. So your goal, the SRE's goal is to drive operational burden to 0, not deal with all the operational problems. And really the key is to start putting your developers on call. So there are 3 main benefits of putting developers on call. The first one is we have ever-increasing demands around performance, availability, reliability, security of our systems, especially microservices. And devs, developers, are often the most qualified people who can solve these problems, considering most problems actually comes after when you change something, when you deploy something. Because they know ins and outs of their code, and again, most of the problems happens when you change something. And the second one is the better alignment of developers and operations engineers, which really is what we are talking about when we talk about DevOps. So when developers experience these problems, this often leads to better testing, better monitoring. So they start caring about operational concerns they didn't care about before. They start caring about instrumentation, alerting, whether alerts are actionable or not, whether they put the right monitoring in the right place. Because now they get up in the middle of the night, not someone from another team that has this as a job. And the third one, we often overlook this one, but it's very important to get the management on board with this DevOps idea as well. And when you start putting developers on call, when you start paging developers on call, it creates a better alignment between management and all the development teams as well, because now management can see the effect of these alerts, these reliability problems, directly on the feature requests. So because developers are developing all those new features, now they have to spend their time on dealing with these problems, not just a team that has solely responsible for dealing with incidents. Now they can see the effect of these compromises that they make while prioritizing feature work over reliability work. It helps management be on board as well. So is there an industry standard, like do we all start putting developers on call and does this, like every company do the same? Of course not. Every company is different. You have to look at your company. Where are you at your journey? Where are you at your let's say maturity level? And even big companies follow slightly different approaches. For example, Amazon goes with total ownership model. Even like teams communicating with each other, they usually do it, for example, with tickets. So they usually think about teams in Amazon as startups, right? They are kind of different companies within a big company. So if a company, if a startup within the Amazon, let's say service team, is creating something new, they are also taking all the ownership, including all the alerts and all the monitoring burden. Of course, there are some reusable libraries and stuff that makes them faster, but they get all the operational problems, all the alerts by themselves. With Google's SRE model, it is slightly different. They found that some services that have, let's say, reliable track, like Google Maps, for example, is proven to be reliable for a long time. It achieves its SLO, service level objectives. Then site reliability engineers, SRE teams, take on call for those services. And if things start going worse and there are multiple breaches of objectives, for example, site reliability engineers are powerful enough to give back on call to developers. So it is very important to give this kind of power to SRE to keep our services reliable. But for new services or services with some reliability problems, SRE doesn't take the on-call. Developers get all the alerts. And with Opsgenie, we follow a slightly similar approach. We also have our SRE team taking on call for some of the things that they built as well. For example, they are responsible for CI/CD, and if there's something broken with our pipeline, they have to deal with that. So we are paging them as well. And also they are in the on-call pipeline. So if, let's say, a developer can't solve something, they can escalate or bring in an SRE and try to work with them to solve the problem. And a great quote from the Site Reliability Workbook. I also have different talks about how to build a healthy on-call culture. It is very important because we tend to make a lot of mistakes that might result in burnouting our engineers. We know how hard it is to find good engineers, so we have to, when we put them on call, we have to invest in making on-call better so that on-call is not really life-impacting. So I really like this quote. The Site Reliability Workbook from Google, they say, we never achieve reliability at the expense of an on-call engineer's health. And the key is following all these best practices that companies like Google share, learn from them, and try to find your own way. It doesn't have to be exactly the same. It won't be exactly the same because they're a huge company, but you can learn a lot from these books. And the third one is about incident response roles, about commanding major incidents. So most alerts are easy to solve. If you have a runbook that shows on-call engineer what steps to follow, how to find what is wrong with your system. But sometimes, especially in microservices where services depends on each other, things can get very complex. You might need multiple teams collaborating together to solve an incident. Some incidents are just high impact enough that you don't want to spend a lot of time, even if it just includes one team. So you have to bring in a team of people that can solve this problem faster. So you have to come up with a planned way of dealing with incidents. You have to define different roles. So when we talk about a team that can solve problems, we talk about 4 major roles involved in this incident resolution process. So the first one, and I think the most important one, let's say, is the incident commander, the person who leads the incident, right? And they say incident commander should even have higher authority than CEO in case of an emergency like this, because you don't want like your CEO or your senior manager join the talk and say, why aren't you solving this problem? You know, it doesn't help anyone, right? So this person, it should be stated before and talk with the managers as well, has to be the one, has to be the person that has the most, that has the higher authority than anyone else in the company, because he or she knows, like, controls all the aspects of this resolution process. That is why this person should know to say no if needed. And one of the most important things when we talk about this role is to be very specific, because this person are going to, you know, coordinate the incident, talk with different engineers, talk with different people with different roles, and it is very important to be clear about the instructions. So you don't want this person to say, like, can someone please take a look at the logs, and, you know, if there is an exception that doesn't help anyone, it can create even more chaos. So, you know, being specific, for example, we want this person to be very specific. Say, let's say, Alex, can you look at the logs for this service if there's any exceptions and return to me in 10 minutes, for example. You know, be very specific with, like, who are you talking to, and, you know, give a time slot so that you can trace what is going on in a complex situation. And the second one is communications officer, because we have a lot of different people involved, and on top of that, we have a lot of different stakeholders. For example, different service teams, or if your service is a customer-facing service, even your customers, so you have to communicate with them, you have to share information with them, and sometimes you have to even get more information from them about potential, like, side effects. So my recommendation is to use a tool like, for example, Opsgenie to automate this process, but also I find it valuable to have someone actually doing this, because even though we try to automate a lot of things, it is sometimes hard to get the most important bits. For example, if you are using Slack to communicate, it is sometimes, you know, important bits lost in the crowd, right? So you have to have someone actually taking notes and recording what is happening as well, which brings us to the role scribe. So we have to have someone responsible for really documenting related to a lot of things about incidents. Like, what did we do in the last 10 minutes, for example, if you want to check that, whether if you want to check a service, like for logs before. And this information can be really helpful. And one of the best use of this information is obviously after the incidents, when we write our postmortem, post-incident review, and try to figure out what did we wrong and what can we do better next time, right? And finally, the role for engineers. Our domain experts who actually are working on solving the incident. Engineers who debug and solve the problems. So sometimes so it is very important to have this training before, so that they know, like, they know that they need to be respectful with each other, considerate, especially, like, given the chaotic situation, given the importance of these kind of incidents. It is really easy to blame someone for, you know, making a mistake. But we have to have this kind of common understanding that blaming someone doesn't help anyone, right? So we have to be respectful with each other and try to follow the leads of incident commander. So it is very important to train subject matter experts as well, or let's say engineers, our engineers. So the next one is tracing, because obviously there are different ways of monitoring our services, but when we specifically talk about microservices, tracing, often we also focus on distributed tracing, is very important. And again, simplicity in monitoring is important because you are dealing with a lot of different services, so you have to make it easy to spot what is wrong find what is wrong with a service. And tracing is a really good way to monitor microservices. It helps you, it gives you a way of observing what is happening in a microservice or an entire system, and it helps you troubleshoot especially latency problems. And tracing can be done within code level or service level or better both. And there are different options that you can take a look at. There are some specifications like OpenTracing or tools like Zipkin, Jaeger, or if you are using a specific cloud provider, they start offering these managed services that make these services make it really easy to work with other tools as well. So a great example is AWS X-Ray. But before I talk a little bit about different ways of tracing, I want to emphasize that we shouldn't expect developers to write a lot of code for tracing. We should make it very easy, if possible, even transparent for them to have this kind of tracing capabilities. So the first way, and the way that I don't really recommend using tracing, is to manually create these traces. Sometimes they're called segments, depending on which service you use. So my examples are from Java using AWS's distributed tracing solution, X-Ray. So especially you might have to use this kind of manual tracing if you are developing a library, kind of something that other teams will take and use. And if you want to provide traces by default automated in an automated way, you can use manual tracing. But otherwise, if you're developer and and using a service, you don't want to just open different sections and just try and catch and session IDs, adding that, and all those kind of stuff creates complexity, and it's really hard to test as well. The suggested way is automated monitoring. So for example, if you are using DynamoDB, what you do to trace DynamoDB calls to different services is to just add a tracing handler for the AWS X-Ray, and that's it. Whatever call you make to another, a DynamoDB table, and that will be available for you to see in the AWS X-Ray dashboard without doing any more coding. Or if you are developing something and if you just add an annotation, it can trace a lot of different things. Yes, and for example, for the automated monitoring, if you are using, let's say, Spring Framework, and if you just add an annotation, you might have different traces for, let's say, service layer, repository layer, or if you have different layers defined, it will be all automatically traced and added as traces on your dashboard. So this is what you see if you go out on the AWS X-Ray dashboard. This could show like some request flow. Again, it's not just about distributed traces between different microservices. It can also show you what is happening within your code if you instrument your code, right? And also, these kind of tools can create what we call service maps, which will help you spot problems for different microservices or even different classes or objects you have in your application that interact with each other, right? And it is very easy, instead of going over the code and trying to figure out what is wrong, just to spot the problem and click and go into the detail, right? So these kind of tools also help you spot problems at a glance. So the last thing we're going to talk about is alerting. And it is one of the most important things, even though it's the last thing, because biggest reason people fail at doing a good job in incident response is that they fail at alerting. They get a lot of useless alerts that they give up at some point, and they don't know what to do during problems. So that is why we have to be data-driven while deciding what to page on, right? And the SRE book has a lot of great suggestions about using service-level objectives to drive alerting. And I just took one of this is the first example from the book. There are 6 of them. So we're going to only cover the first one, and this is the easiest one, especially the sixth one is kind of complex. It has additional benefits, but also making it complex, is creates additional challenges as well. For example, for this one, we decided to, let's say, create alerts when our target error rate is bigger than our SLO threshold. So what we mean is, for example, we have an SLO that has 99.9% availability target over 30 days. So if we create an alert, once our error rate is bigger than 0.1%, which is our goal, right? Because we have 99.9 target, is we create an alert for when our error rate is bigger than 0.1 over 10 minutes, then this has additional benefits, right? Because we have a good recall. I mean, we will get the alert immediately once our service is breaching our objective. Detection time is actually really good with this one. For example, for a total outage, let's say your service is down, you will get an alert within 0.6 seconds with this one. But the disadvantage is, even though this exhibits good recall, this alerts fires on any event that threatens SLOs, and with that, that might mean there might be many alerts. Even like in the extreme case, you might receive 144 alerts per day, every day, not act upon any of the alerts and still meet the SLO. So, you might get a lot of alerts, but you still didn't breach your overall SLO for 30 days. So there are advantages of disadvantages of each way. I suggest you take a look at them and decide what is best for your case. But this was like one of the easiest ones. So this is an example from our Atlassian's incident response handbook. We just published a new incident response handbook on how we do incident response at Atlassian. And we use different severity levels for different things. For example, we have a severity level 1 alert for a critical incidents that have a very high impact. So what we should be defining what is a high impact for and make it easy for our engineers. Obviously, we should make this kind of decisions automatically if we can, but sometimes it is, we don't want to declare a severity level 1 kind of alert and page a lot of people and declare an emergency without making sure that there's actually a big problem. So we have some examples. For example, if there's customer data loss, or if a customer-facing service like Jira Cloud is down for all our customers, that is definitely a severity level 1 incident. And for example, if we have a still major incident with significant impact, and we should define what significant is. So it might be a customer service, customer-facing service, for example, that is unavailable for a subset of our customers, or a core functionality for Bitbucket, for example, is failing. That is also a severity level 2 incident for us. But there are also incidents that has, let's say, minor incidents that with low impact. There might be some workarounds available or some performance degradation for subset of our customers. Those kind of incidents, we don't need to bring the incident response team and alert everyone. So we have to have, so in Opsgenie we have 5 different severity levels, for example, by default. You can customize those as well. So, in microservices, we have to especially focus on a couple of important things if we want to scale our alerts, because there are like multiple services, and if you think about thousands of engineers with hundreds of different microservices, that might be a problem. Especially there are a lot of different alerts for different metrics, and it might be a chaos for different teams. So so you have to do your best to suppress noise, stop alerts pages as necessary, filter them, filter the unnecessary ones, and delay the minor ones, and just make them available for engineers to work on them in the morning, not in the middle of the night. And most incidents are most incidents trigger more than one alert, so it is important to have this kind of capability to group them under one incident and see them all together. Because if there are, let's say, side effects of when you're dealing with an incident, you have to separate those, or there are other incidents, you have to separate those incidents from the incident you are having at the moment. And also you have to have like a common view of this one incident that you are dealing with, because you are also, you might have different tools, like for infrastructure monitoring, for your logging, or for APM, for example. And it is really important to bring all those together and have a common view, and those will also help you solve the problem faster. So the last one is using similar alerting parameters across different microservices. So if you have, let's say, 100 different microservices and different alerting parameters for each service, this can create, this can accumulate toil, a necessary term, for things that are repetitive and things that doesn't really help us moving forward, moving fast. And this can create cognitive load that doesn't scale in your teams. So try to have common parameters, just like the one example I gave. Like if your service is talking with different services via HTTP requests, you might want to set up an HTTP alert around HTTP request parameters, instead of coming up with different parameters for each service. And it is important to point out that production ready doesn't mean when you send your code to production. It means you can detect and fix problems early enough to keep your customers happy. So if you don't have the necessary monitoring, necessary practices to deal with all those incidents that are going to come up, and your code isn't production ready. So with that, I want to recommend a couple of links that help me learn more about this topic. Our incident handbook, this is really valuable, and it has a lot of different things about blameless postmortems, on-call practices as well. And the site reliability engineering book and workbook. And the last one is an online magazine called Increment. If you haven't read about it, I really suggest you read different. Like they have, I think they released like eight issue. And the last one, for example, is about security. So they focus on different issues in each one. And the first one was on call, because on call really matters. And the two books I recommend is the Site Reliability Workbook, and there's this book called Incident Management for Operations Engineers. And this book gives examples, like takes examples from firefighters, like how they respond to fires, and apply those practices to IT teams, like how we can learn from these emergency responders and bring those best practices to our teams. It's really valuable. It's a short book, relatively short book, 80 pages or so. So I really recommend you using that one as well. With that, I want to thank you for attending my talk.